Blockchain explained. Understanding the technology behind cryptocurrencies. A blockchain is a relatively new kind of database that has become the trendy solution for storing digital information more securely. The International Data Corporation recently forecast that companies and governments will spend $2.1 billion on blockchains in 2018, more than double what was spent last year. But if you ask even the people who work with blockchains to define the technology, you are likely to get a stuttering response. Don't blockchains have something to do with Bitcoin? The first blockchain was the database on which every Bitcoin transaction was stored. Since Bitcoin began in 2009, the blockchain has come to hold over 160 gigabytes worth of data about every time a Bitcoin is sent between two digital wallets. Why is it called a blockchain? In the original documents describing Bitcoin, the virtual currency's new database was not referred to as a blockchain. But it got that name over time because all of the transactions coming onto the network were grouped into blocks of data and then chained together using sophisticated math. That makes it hard to go back and rewrite or monkey with the older records. Academics have pointed out that this design existed before Bitcoin, but Bitcoin brought it to prominence. How is the blockchain different than other databases used to store transactions? Most databases used to keep financial records are maintained by a central institution. J.P. Morgan Chase, for instance, is responsible for keeping track of how much money is in all of its customers' accounts. With Bitcoin's blockchain database, the ledger is kept and updated communally by all the computers that are hooked into the Bitcoin network. The communally maintained nature of the Bitcoin blockchain has brought it comparisons with Wikipedia, which relies on a broad network of contributors rather than one author. The shared nature of the Bitcoin blockchain was useful for the virtual currency because the shadowy creator of Bitcoin, known as Satoshi Nakamoto, wanted to create a currency with no central authority involved. Because the records are kept communally, no one computer or institution is in charge. If any one computer keeping the records is hacked or knocked offline, the other computers can go on without it. Are all the blockchain projects tied to Bitcoin in some way? No. Most blockchains have nothing to do with Bitcoin. After the Bitcoin blockchain had operated for a number of years, successfully storing every Bitcoin transaction and surviving numerous attacks from hackers, many programmers and entrepreneurs wondered if the design of the Bitcoin blockchain might be replicated to create other kinds of secure ledgers, unrelated to Bitcoin. Are blockchains used only for recording virtual currency transactions? No. Most of the early efforts to imitate the Bitcoin blockchain were done by programmers looking to create virtual currencies with slightly different characteristics from Bitcoin. And that needed their own databases to store all the transactions. Over time, some of these new virtual currencies added on significant new features that updated the blockchain concept so that it could handle more kinds of information. The most valuable virtual currency other than Bitcoin is Ether, which runs on the Ethereum blockchain. In addition to recording virtual currency transactions, the Ethereum blockchain can record and execute simple programs. It is possible, for instance, to create a program on the Ethereum blockchain that will move Ether between wallets only after a specific event. More recently, many companies and governments have been interested in using blockchains to store data that has nothing to do with virtual currency transactions or transactions of any sort. While banks are building blockchains that can track payments between accounts, governments are experimenting with using blockchains to store property records and votes. Why is this unusual way of storing data something that companies are excited about? There are several limitations that come with the old way of keeping data, with a single authority responsible for all the updates. When a database is maintained by a single authority, if that authority gets compromised by a hacker, or even by natural disaster, the people relying on that database can lose access to all their data. With a blockchain, all the people relying on the database can keep and update their own copy of the data. Apart from the security, a lot of data is kept in a way that requires all the players to separately keep track of the records themselves. Banks, for instance, keep track of every transaction they do with other banks, even though the other banks are also keeping track of the same records. It costs a lot to make sure everyone's records are in sync. Blockchains can potentially provide a more efficient way to do this so that everyone is always on the same page. If blockchains involve multiple computers all keeping track of data, what if they disagree? This issue, of how to keep everyone on the same page, is what the most important, but also the most confusing, bits of blockchain technology are aimed at resolving. In Bitcoin, the process of mining, or creating new Bitcoin, also has a second purpose of making sure everyone is making the same updates to their copy of the blockchain. Most virtual currencies have used this process to coordinate everyone on the blockchain. When blockchains don't have a virtual currency, they have to find a different mechanism to get everyone to agree on new additions to the ledger. These mechanisms are called consensus algorithms, and they are among the most contentious pieces of blockchain design. Can anyone join any blockchain and help update the records? With most large virtual currencies, anyone can join in and see and help maintain the records. These are called public blockchains. This system has made many big players looking at the technology uncomfortable. Consequently, most corporations and governments have worked with so-called private blockchains, which only approved computers can see and join. Haven't all the thefts involving Bitcoin shown that blockchains aren't secure? Most of the thefts involving virtual currencies are a result of people's having the password, or private key, to a virtual currency wallet stolen or hacked. Virtual currencies are particularly vulnerable to this kind of attack because once a hacker moves money out of a wallet, there is no central authority to move it back. Any blockchain wallet or account is generally only as secure as its private key. While private keys are a security vulnerability, blockchains are generally more secure against attacks in which a bad actor tries to change the records in the database. Because of the way blocks are chained together, it is obvious when someone has tampered with old records. Do we know if blockchains really are better than old ways of recording data? We don't, really. Virtual currencies have shown that blockchains can work at some level, but they also come with significant downsides. Because all the computers on the network have to record every transaction, there are limits to how much data blockchains have been able to process. There are many efforts to fix this, but none have been proven to work. Many critics of the blockchain design have said the inefficiencies in keeping data communally are likely to make blockchains unattractive except in cases where centrally kept databases are a major liability. At this point, aside from the big virtual currencies, few blockchains have been used and battle-tested in the real world for any amount of time, which leaves significant questions about how they will perform once they make it into use. If you find this video useful, don't forget to like and subscribe to our channel.